Hi, everybody. I wanted in this ethics of testing and screening chapter of biomedical ethics to talk about just a couple of issues through video because I think it's going to be a little bit easier to explain them than it will be through the writing itself. As with all the other chapters, you're still going to have that writing. You'll have the notes that you can refer to. You can use those for any case studies that you might be using for the final exam or for your research or anything like that. But because testing and screening is happening right now with the coronavirus that we're all dealing with, I thought I would talk about those issues, in particular the ideas of sensitivity and specificity when it comes to testing. Because part of the problem we're having with COVID-19 is that the tests that we're using aren't necessarily sensitive enough and others aren't specific enough. And this balancing act is part of the problem with testing in general. And this works really well to show how that works. So as we do this, turn to page 281, and you'll see information about false positives and false negatives. In particular, that tests should be both sensitive and specific. Sensitivity, as you can read there, is the ability of a test to detect infection when it is present. In other words, to give a positive result when it should be giving a positive result. In other words, when someone actually has the condition. The specificity of a test is the ability of a test to detect the absence of an infection if the sample is uninfected. In other words, to return a negative result when it should actually be negative, right? So one of the problems that we're having with COVID-19 tests is that in the early days of testing, there were reports that the sensitivity of some of these tests were as low as 60%, which basically means that 60% of the time, if a patient was positive for COVID-19, then we would get a positive result. But that means that 40% of the time, we weren't getting a positive result, even though we should have been. Now, this could be because it's asymptomatic and maybe what it was testing for is somewhat hidden as far as the tests are concerned. In other words, they can't quite pick it up even though it's there. I'm not exactly sure why this was happening. Again, this is pretty early. But even if it were at, let's say, 90%, in other words, 90% of positive cases would register as positive, that would still mean that 10% would not. So if we're testing, let's say, 1 million people, or 1 million people who have the virus, and our sensitivity of the test is 90%, which sounds really high, it still means that 100,000 people who are positive, in other words, who have the virus within them, were not tested as positive. And so they're going on about their lives thinking that they're okay when they're not actually okay. This can be a problem. So as you think about this sensitivity and specificity of tests, keep that in mind that this has real world results. The other thing that I wanted to talk about through the video is cost. So one of the problems that we're going to talk about later in the chapter is on 290 to 291, and this is the cost of certain tests. And costs are often measured by how many cases we actually get for the test that we run. So in other words, we're not just going to say, well, we ran 1,000 tests, they were $10 a piece, so that cost $10,000. We also kind of want to know, well, how many cases did we actually catch with this? Because this gives us the effectiveness of the test. So maybe we ran 1,000 tests, but we only caught one case. So we spent $10,000 to catch one case, and that cost us $10,000 per case detected. Or maybe we caught 5 cases, which means it costs $2,000 per case detected. And I wanted to talk about a study that's actually not in our book. I have it from somewhere else. In the mid-1970s, the American Cancer Society wanted to do 6 sequential guaiac stool tests to check for colorectal cancer. These are hard to detect sometimes, but if you catch them early enough, you can save a lot of lives. So they thought if we did a round of 6 of these, then even if we were getting false negatives in some cases, we could catch them in the next round. So someone might think they're safe, but they're not safe, right? The test didn't work. They didn't get the right result. So by doing the test again, you can catch it the next time. In other words, they were told that it was negative, but it wasn't negative. It was a false negative. That's a specificity problem. Anyway, So the government did an analysis. Remember, this is the mid-70s to try to figure out what this would be. They assumed the initial test would cost $4 and that each additional test would cost $1. I think that's because the initial test is collecting the sample, doing all that, getting it to the lab, etc. After that, they can test it again and again and again at a slightly lower cost. Even so, they determined that on the first round of this testing, the marginal cost per case detected, meaning the effectiveness of the test, would be $1,175. So that's how much we would be paying per person caught. That's not bad because you've saved a life, right? But remember, they wanted everyone to get this, and not everyone has colorectal cancer. So the second round of tests would cost $5,492. That's jumping. That's about 5 times as much. But again, you're saving a lot of lives. For 3 rounds of testing, it suddenly leapt up to $49,150 per case caught. You can probably see where this is going. If we did 4 rounds of testing, it jumped dramatically to $469,000 per test that actually worked and caught something, right? Remember, they wanted 6. So when we get to the 5th round of testing, we're actually paying $4.7 million for each case that is detected. Now, for the person whose life was just saved, that might seem worth it, but that's an awful lot of money to spend. And we still have 1 more round to go. That last round would cost $47 million for each case that we detected. Now, the prices keep going up because remember, this is only trying to catch people who passed the previous round. So someone has to go through 5 false negatives before they get to the 6th round of testing. And then they'd still have to test positive after that, which seems very unlikely. It's increasingly unlikely as you go through each phase, obviously. And so, as you can imagine, the government, after they ran this cost analysis procedure, decided this really isn't worth it. Maybe we could justify doing 1 round of this. Even that was over $1,000 per case caught. If you're thinking about every single person getting tested for $4, if we have 300 million people like we do today, it's a little over that, but that's going to be a lot of money, right? You're talking about over $1 billion in order to just do that first round. Again, though, that would save lots of lives, but it's pretty expensive. We'd have to figure out who's going to pay for it. Anyway, I hope that this gives you some examples that can help you with understanding both sensitivity and specificity and the idea of cost when it comes to mass screenings. The rest of this will be in the notes for the chapter, and I hope all of you are staying safe and healthy.